When the RMS Titanic set sail in 1912, it was not just a ship, it was a floating powerhouse. Please subscribe. Beneath its elegant decks and luxurious interiors existed a massive mechanical system. At the heart of Titanic's propulsion system were its steam engines. These engines did not run on fuel in the way modern engines do. This process began in the ship's boiler rooms, where enormous boilers heated water to produce steam. The scale of this operation was immense, requiring a constant supply of coal and continuous manual labor. After doing its work in one stage, the steam moved to the next stage, expanding further and extracting more energy. This process repeated across 3 cylinders, maximizing efficiency. The pistons moved up and down with tremendous force, converting the energy of steam into mechanical motion. This motion was then transferred to large shafts connected to the ship's propellers. As the shafts rotated, the propellers pushed against the water, driving the ship forward. But Titanic's system did not rely on just one type of engine. In addition to the 2 main triple expansion engines, there was a third component, a steam turbine. This turbine used the remaining energy in the steam after it passed through the main engines. Instead of pistons, the turbine used spinning blades, capturing energy that would otherwise be wasted. This combination of engines and turbine made the system more efficient and powerful. The coordination between these components was critical. Any interruption could affect the ship's movement. This required careful monitoring and control by the engineering crew, who worked in challenging conditions below deck. Temperatures were high, noise levels were constant, and the work was physically demanding. Workers had to manage coal, maintain equipment, and ensure that everything operated smoothly. Their efforts were essential to keeping the ship moving. Orders were sent to the engineers, who adjusted the engines accordingly. This coordination allowed the ship to respond to changing conditions and navigate its course. It was designed to provide enough force to move the massive ship while making effective use of available energy. However, like all systems, it had limitations. It depended heavily on manual labor and required constant attention. The complexity of the system meant that it could not be adjusted instantly, and changes in speed or direction took time to implement. Looking back, the engine system of the RMS Titanic is a fascinating example of early 20th century engineering. It shows how large-scale mechanical systems were designed and operated before the advent of modern technology. It also highlights the human element behind the machinery. The engines did not run on their own. They were powered by people, by effort, and by coordination. Every movement of the ship was the result of a system working together, from the boiler rooms to the bridge, not just because of what happened, but because of how it worked. It represents a moment in engineering history where ambition, design, and human effort came together on a massive scale. In the end, the engines of the RMS Titanic were more than just machines. They were the force that moved the ship, the power beneath the surface. And for a brief moment in time, they carried one of the most famous ships in history across the ocean, driven by steam, strength, and human determination.